Hi, I'm Anna Carnes, and this is my Lab 5 presentation. I did this presentation over projectile motion and the energy principle. The purpose of this lab is to use the energy principle and the momentum principle, which I derived from Newton's second law, to accurately predict projectile motion and calculate the work done on an object in projectile motion. The procedure for this lab was to record a video to use in Tracker. In Tracker, I collected data from the actual motion. Then, using the initial velocity and the principles I learned in this class, I created a GlowScript code to create a computer model to try and accurately predict this motion. Then I created a graph to show the combined data to see how accurate my model was. The formulas I used were the momentum principle, which I derived from Newton's second law, and the energy principle. The momentum principle can be derived by taking the final velocity is equal to the initial velocity plus the net force divided by mass times delta t, and then you multiply everything by mass, which gives you the final momentum is equal to the initial momentum plus the net force times delta t. Next, you divide everything by delta t, and you get the momentum principle, which is delta p over delta t. For the energy principle, the only outside forces that we know of are the initial force of the throw and gravity, assuming that drag is negligible. There is no change in thermal energy, so we focus on the changes in kinetic and potential energy. The formula for kinetic energy is 1/2 mass times velocity squared. Here is my tracker data. First, I changed the frame rate to match the frame rate of my phone, which was roughly 0.03 seconds. Then I centered the axes around the ball's initial position. Then I placed a marker in the center of the ball once per frame to track the motion. And on your right, you can see the graph of the points that I plotted and the data in the table that goes alongside that. Here is my combined tracker and GlowScript data. As you can see, my data is a little bit off. The X position data was very accurate, but the Y position data was more off. This is probably due to human error. I likely didn't place the marker in the exact center of the ball each frame, and I did ignore drag. There could be other forces, like a wind acting on the ball. I might have left something out of my calculations, or even made an arithmetic error. However, overall, I think my graph is very accurate.